Hello everyone, this is Dr. Srinivasulu, Assistant Professor, Department of Electronics and Instrumentation Engineering, VNR VJEC, Hyderabad. In this video, I am going to explain you the types of errors of measurement. Before going to the types of error, let me explain you what is the measurement error. Basically, we take the measurement from the instrument, and when we take the measurement, it may not be actual measurement, like what will be the standard value that we need to get from the instrument may not be the same when we measure from the instrument. So basically this difference is defined as the error, and the actual standard value of the measure of the value is called the true value or actual value, and what we obtain from the instrument when we take the reading is called the measured value. So the difference is the error. This is very common in any measurement, but we need to understand what type of the error is to minimize the error when we take the readings from the instrument. So these are the types here given: the gross error, systematic error, and random error. These are the basic types of errors in the measurement. Now we will explain one by one. So this is the tree structure of the errors in measurement. Basically the error is divided into gross errors, systematic error, and random errors as explained. And again these systematic errors here further classified into instrumental errors, environmental errors, and observational errors. The instrumental errors again may be due to the loading effect or misuse of instruments or inherent shortcomings of the instruments. Anyway, we are going to discuss these types of errors in detail one by one. First one is the gross error. The gross error is basically due to the human mistake. When we take the reading from the instrument, because of the human mistakes, because of improper recording of the value, this type of error will arise. But to overcome this gross error, there is no 100% solution, but we can reduce the gross error by avoiding the human mistakes, by noting down the proper value of the measured value. We can avoid the gross errors. So the careful recording of the measurement value is required. And also one of the solutions is we can take 2 or more recording or reading values to avoid the measured error. And also we can take the values or measured values by different people, so we can avoid the gross errors. And next type of error is the systematic errors. This is already I have shown in the tree structure. The systematic errors are further classified into instrumental errors, environmental errors, and observational errors. The instrumental errors are basically due to the inherent shortcomings of the instrument, because of the manufacturing defects or variety of shortcomings. Sudden changes happened in the instrument while it is measuring the values, it will arise. And the misuse of instrument, because of the misunderstanding or not knowing how to take the recording or reading from the instrument, this kind of errors will be arised, instrumental errors, because of that misuse of instrument. It may sometime out of the range if you try to read or measure the values. These kind of instrumental errors will arise. And also due to the loading effect, when you take the recording, because of the additional instruments or components or measuring devices load, will be added to the circuit or to the other parts of the instrument and will get the error. So the instrumental inherent shortcomings of instruments is due to the errors uh, because of the manufacturing defects. For example, if the instrument is having a weak spring, then when we add the load, even it is within the range, it may not sustain, it may break, or it may give very high values or very low values instead of getting the actual or very close to the actual values. So this is one type of instrumental errors. If there is a sudden fluctuation happen and sudden high current passes through the circuit also, it may go damage or it may go to saturation some components in the circuit, so it will get some instrumental error. And misuse of instrument is because of the experimenter, or some instruments will work within the same within a prescribed or specified range. Because of the failure of the system when we use outside of the range, or improper adjustment of the instrument, a poor calibrations, so these are the reasons for the instrumental errors because of the misuse of the instrument. To avoid this kind of errors, we need to properly calibrate it, and before starting the experiment or before taking the measurement, we need to initially adjust the instrument to the zero level, then we need to take the measurement. And the loading effect is very common when we use the instruments, when we use the measuring devices to the circuit or to the instrument where we are measuring the value. Because of the measuring device also has some load or resistance that will be added when we connect to the measuring part. This, because of the additional load or not suitable load connected to the measuring unit, it will give the wrong reading which is not close to the actual value. Here I will explain clearly what is the loading effect, how it will arise by taking a simple circuit example. Say there is a resistive circuit, the two resistors are connected in series, and this circuit is having the applied voltage of 10 volt, suppose say, and assume this resistor value is 90k and the second resistor value is 10k. And now we want to measure the voltage across this 10k. If you don't connect any voltmeter across this 10 kilo ohm resistor, and we try to first get the actual or true value theoretically, just for comparison and to understand the measuring error effect. Here the voltage across 10k is, suppose say, V10. Therefore V10 is equal to, by the voltage division rule, 10 into 10k by 10k plus 90k. This is equal to, when we calculate this will be very close to, sorry, this is equal to 1 volt. And now we'll connect the voltmeter across this 10k resistor. So this is the voltmeter connected here, and assume the internal resistance of this voltmeter is 10 mega ohm. Okay, then we'll calculate the voltmeter reading, that is the measured value. This is say the meter reading, that is Vm, is equal to 10 volt into, again by the voltage division rule, it is, here it is not simply the 10k in this case, because the meter resistance 10 mega ohm is in parallel with 10 kilo ohm. Therefore, it is the parallel combination of two resistances, 10k into 10 mega ohm divided by 10k plus 10 mega ohm, whole divided by this 10k plus 10 mega ohm by 10k plus 10 mega ohm plus 90k. This, when we calculate, this will be approximately 0.99 volt. See here, the meter reading is not exactly equal to the actual value. It is not equal to 1 volt. It is approximately equal to 1. So there is an error here. So we'll calculate the error. Error in this case is equal to V10 minus Vm. This is equal to 1 minus 0.09 volt. 0.99. This is equal to 0.001 volt. This is the error when we use the voltmeter with internal resistance of 10 mega ohm. Now we will take the voltmeter internal resistance of different value. That means we are using a different voltmeter to verify the loading effect. Let me take the voltmeter resistance now. The RMA value is equal to 10k. So instead of 10 mega ohm, in this case I am taking 10 kilo ohm. Whereas here internal resistance of meter was 10 mega ohm. Now here Rm is equal to 10 kilo ohm. So I selected a voltmeter of 10 kilo ohm internal resistance. Now we'll repeat the same calculation. Anyway, the actual reading is same. 1 volt is same, the actual value. Now the meter reading only will calculate. Vm is equal to 10 into, here the parallel resistance is 10k and 10k because the Rm is 10k now. So 10k into 10k divided by 10k plus 10k. 10k into 10k by 10k plus 10k plus the series resistance is 90k. When we calculate this, we will get approximately equal to 0.5 volt. So now we see voltmeter reading is 0.5 volt instead of the actual value 1 volt. Therefore, the error is V10 minus Vm is equal to 1 minus 0.5 volt, that is 0.5 volt. The error is 0.5 volt. So when we compare these two cases, we can understand clearly that the voltmeter, when we connect to the circuit for the voltage measurement, the internal resistance should be higher. So in these two cases, the 10 mega ohm internal resistance voltmeter is the best suitable device to measure the voltage with less error. So the loading effect is when we use low resistance or improper or extra load to the actual circuit or measuring unit, that device load is also adding and producing some error. That is due to the loading effect. We'll get some instrumental error. And how to solve this, how to minimize this? By selecting the proper device, measuring device with suitable measurements, suitable internal resistance, etc. for minimizing the error. Now the last one is the environmental error. This is very common, which is not avoidable, but the environmental error is basically due to the external effects, external environmental, where we conduct the experiment to measure the values from the instrument or measuring unit. That external environmental conditions like humidity, temperature, pressure, etc. will involve and affect the measurement of the instrument. So to avoid this kind of external environmental errors, we used to conduct the experiment in a controlled environment so that we can avoid these errors. Like controlled environment in the sense it can be a constant temperature, or it is a very shielded protected case. Also we need to properly ground or external fluctuations to be avoided. All these conditions we need to uh, take care of it to avoid this environmental errors. And the observational errors will get when we take the readings. We will take the readings at different angles by just looking at the measurement. In some cases, suppose the water level we want to measure, the scale is provided on the tank or the tube. So when we look at different angles, the value will be, our scale marking will be, we can observe at different values. So to avoid this, we need to focus or constantly closely observe this and get the recording. Or by taking from different experimenters, we can avoid these observational errors. And also the best example for observational error is the parallax error. Basically the analog meters will be having the mirror to avoid these parallax errors, where the aluminum coil deflection is coincide on the mirror, then that reading will be helpful to avoid the parallax errors. And the random errors are basically it which are not properly predictable, and it is unavoidable and unknown things. But mostly the random errors can be approximated but cannot be exactly defined. So to avoid the random errors is very difficult, but we can approximate it and we can minimize it. Thank you. Thank you for watching this video.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.